In the last video, we discussed the electrostatic force. In chemistry, we talk more about energy than forces. This brings about many questions. What is energy? Where does it come from? Where does it go? Does it get used up? How can we store it? In this video, we'll address how do forces influence energy. Energy is difficult to define. Let's take a look at this quote from the Feynman lectures by physicist Richard Feynman. We know how to calculate the value of energy in different situations. We also know that total energy before and after something happens remains the same. This is known as the conservation of energy. But energy in itself is an abstract concept, and we have a limited knowledge of it. Energy is typically defined as the potential to do work. But this definition is unsatisfactory because it raises the question of what is work. Work requires force, and force requires energy. So instead, we have a circular definition. We know that any change in matter is accompanied by a change in energy. Also, changes in energy are caused by changes in forces. Lastly, as we discussed in the previous slide, energy is conserved. And finally, energy has units of joules or in calories as well. Remember the Feynman quote mentioned the conservation of energy, meaning that the total amount of energy remains the same before and after something happens. To study the changes in energy, we need to define what we are studying. When we discuss energy, we will focus on the system. The system is the part of the universe that you are looking at or studying. Focusing on a system makes the task of measuring the changes in energy easier. The surroundings are everything else. Systems and surroundings together constitute the universe. We can monitor changes in energy by searching for differences between a system and its surroundings. In the end, energy is never lost. It can be transferred or transformed. This is known as the first law of thermodynamics. In chemistry, changes in energy are often observed as changes in temperature. Through this point in the video, you may have been thinking, I already know several types of energy. You may have considered thermal energy, hydroelectric energy, nuclear energy, kinetic energy, solar energy, potential energy, chemical energy, mechanical energy, elastic energy, electromagnetic energy. There are a bunch. But at the molecular level, nearly all forms of energy can be related to one of two types of energy: kinetic energy and potential energy. In the last video, we discussed electrostatic forces, which would relate to electromagnetic energy. However, even electromagnetic energy can be related back to potential and kinetic, but this is a relationship that we're going to discuss later. Kinetic energy is associated with motion. It is expressed by the formula Ke equals 1/2 mv squared, where m is the mass of the object and v is the velocity of the object, which is squared. Let's bring back Katie from our previous examples. Here, she's dropped a ball and it's falling to the ground. What is happening to the kinetic energy of the ball? The velocity of the ball would gradually increase due to the force of gravity, so the kinetic energy of the ball would also increase. Potential energy is the energy associated with the position of a system of objects in a field. But what does that really mean? Well, potential energy exists between objects in a field, whether it be gravitational, electric, or magnetic. At the same time, potential energy exists between two or more objects in the field. Sometimes we call this stored energy, but this can be a bit misleading. So, potential energy is a property of a system of objects, and it is wrong to say that an object, such as a ball, has potential energy, despite that's how it's commonly said. More correctly, we would say the potential energy associated with the system of the ball and the Earth interacting through a gravitational field. the potential energy of the system of a ball and the Earth within a gravitational field increases as the distance between the ball and the Earth increases. Potential energy that we commonly encounter is associated with some form of gravitational field. Now let's bring Katie back again for another concept test. The ball is again falling down, and as the ball moves towards the ground, what is happening to the potential energy of the system containing the ball and the Earth? In this case, the potential energy would decrease. To explore this more, draw a potential energy curve for two objects that attract each other, and then draw a potential energy curve for two objects that repel one another, and see what you get. Now let's think about the kinetic energy of the system. Here is Katie again. The ball is falling down, and as the ball moves towards the ground, what happens to the kinetic energy of the system? Here the kinetic energy would increase as the velocity of the ball increases. Now let's think about what causes the potential energy to decrease. The potential energy of the system decreases due to the position of the objects that are in the field. As the position of the objects in the field change due to the gravitational force, the potential energy decreases because they're getting closer together. But what caused the ball to fall to the ground in the first place? The gravitational force causes the ball to fall down. Remember, the force also causes the change in potential energy. One final concept test for today. As the ball moves towards the ground, what happens to the total energy of the system, including the ball and the Earth? In this case, the total energy will remain the same. Remember, the energy is conserved, so the total energy will not change while the potential energy is converted into kinetic energy. As an example, here is a Newton's cradle. When a ball is raised, the system has potential energy. When the ball is released, the kinetic energy increases while the total energy remains constant. Kinetic energy is transferred through the collisions, so energy can be transferred from one object to another, and it can also be transformed from one form into another.